This is an earthquake accelerograph, and this is an Audi RS5 V8 at Phillip Island racetrack. So today we're at Phillip Island racetrack in Victoria. We've got an accelerograph inside this car, and we're going to see if we can use it to record the acceleration as we do laps around this Grand Prix circuit. Now ideally we would have had the accelerograph aligned with the car, but once we've connected the power into the port and connected the power cable to the accelerograph itself, the only way it would fall in was at 45 degrees, which means we'd need to rotate the data in post-processing, which we can do with our Wave software. So what's going to happen now is that as we're driving around, we'll record the data continuously, but we'll also record the latitude and longitude each second, as well as the peak G for that previous second. There's the G for each channel, so east-west is in this axis, north-south this way, and up-down obviously. So now that we've collected our data, it's time to download it and do some data analysis. So we just have to open up the accelerograph and remove the SD card, put it into a computer and download the waveform and CSV files. So the data on the card is stored in a data folder in year, month, day and hour folders. So they're all the folders. So if we open up the days that we were at the circuit, we can see the 5 sessions that we drove and the drive home at the end. So now we need to rotate the seismograms to align with the car, and you'll see that most of the acceleration is in the north-south channel, which is the acceleration and braking. The peak acceleration is about 1.7 G when we're accelerating, which is in the down direction. Forces go backwards. So let's have a look at one of those. You can see whenever we accelerate, the force goes down towards the south, towards the back of the car, and the horizontal acceleration is in the corners, and we exceeded 1 G horizontal acceleration as we're travelling around. So even when we go back and have a look at the whole trip, it's interesting to see that on the vertical channel that the roads are much noisier than the circuit. The circuit's obviously very smooth. So let's look at the CSV file, so the histogram file. So the seismic recorder records the peak G and latitude and longitude along with a whole bunch of other parameters. And so if we snip those out and put them into a separate Excel spreadsheet and put in a formula that calculates the speed by taking the lat and long of 2 points and dividing it by the number of seconds that have passed, say over 5 seconds, and then paste that into a GPS visualizer website. It creates a KML file, which is a Google Earth file. So we're going to be plotting the lat long, speed and peak acceleration. So now we open that up with Google Earth, and we'll see we've just taken one lap, and we can see the plot overlaid over the track. So what we've done is plotted the speed as an altitude, so the higher the point, the higher the speed. So we can see down the straight here we achieved about 240 kilometers an hour, and as we click on a point we can see what the peak G was, so in this case 1.25. So that's our day at Phillip Island. We got to see some really cool cars. Great fun around the track with an accelerograph.